everybody, this is the final video for chapter 12a where we are going to look at recursive rules with sequences. So recursive rules seem a little confusing, but I'm going to do my best to simplify it and it's not so bad, okay? So recursive equations for arithmetic and geometric sequences. So there's kind of some new notation here, but stuff we've seen before. So like there's some for arithmetic sequence, geometric sequence, and we combine them. But we're going to have this a sub n is equal to a sub n minus 1, and you're kind of looking for to see the difference, that d for common difference, or there will be an r out front for the common ratio. A sub n is the current term, a sub n minus 1 is the previous term, and a sub n plus 1 is the next term. Okay, I know that seems confusing, but bear with me, this isn't so bad. So it says evaluate recursive rules, right? The first 6 terms. So here, we see that we've got a sub 0 equals 2. Okay, well that means that the 0 term is 2. So I'm going to write down a 2. And if you want, we could make a little note that that's the 0 term. Okay, so that's not really part of the sequence. And I guess I could write that down. Is not part of the sequence. Okay, so just that little side note. Now, when we read this piece right here, what we're looking for is either that R or the D for the common ratio or common difference, so we can see what's happening each time. I don't see an R, but I do see a common difference, minus 3. So that means that we're subtracting 3 from the previous term each time. So I guess I can make a little note of that. From previous term. So each time we are going to be subtracting 3. So 2 minus 3 would give me minus 1. Subtract 3 again, that'll give us negative 4. Subtract 3 again, that'll give us negative 7, negative 10, negative 13, and negative 16. So notice we subtracted 3, and we're done. Remember, this is a sub 0, that's the 0 term, and it wanted the first 6 terms. So that's 1, 2, 3, 4, 5, 6. That wasn't so bad, was it? Okay, let's look at the next one. So it says find the first 6 terms of the sequence. So it gave us something here. A sub 0, the 0 term is 3. So I'm going to write that down. Remember, a sub 0. Now let's look. What is it telling us to do each time? So I don't see an R, but I do see a common difference of adding 7. Okay, so we're going to add 7 each time until we have 6 of the terms. So that would be 10, 17, 24, 31, 38, and 45. And we did add 7 each time. So now we are done. So that wasn't so bad. So now let's go to another one where maybe it's a little bit different without just the common difference. Let me erase that here for you. So find the first 5 terms. All right, so I see here our 0 term is 243. So let's write that down. All right. So what this is telling me to do here, I do see an R and I see a common difference. So what's happening is we need to multiply by 1/3 and add 9. Ooh, okay. So that's where our calculator can come in handy. So we're going to start with 243. And I'm going to multiply that by 1/3. Then I'll add 9. So our next term is going to be 90, and that's our first term. Then we can take 90 times 1/3, and then plus 9. So that gives me 39. All right, then 39 times 1/3 plus 9, that gives me 22. Okay, so we've got a first term, second term, third term. We need 2 more. And those are going to end up being 16.33 repeating and 14.4 repeating. All right, good. We just have a couple more here. So now we're going to learn how to write the rule. So recursive rules, so this says the rules given in the last examples were recursive. A recursive rule gives the next value as a function of the previous one or more values. That's the formal, kind of definition of a recursive rule. And we're going to learn how to write our own. Before, we were evaluating the rule, but now we're going to write one all by ourselves. Okay? So, So what you're going to do, no text box, okay, is we need to right away, when you start with writing a rule, all you have to do, just write down a sub 1 equals, and then write your a sub n equals, and then write a sub n minus 1 and give yourself a little space for either an r or a common difference, either your common ratio or common difference, right? Depending on what's happening in the sequence. So just leave a little space. So now, our first term is 1. So I'm going to plug in a 1. Now let's see what's happening each time. So it looks like we're adding 6 each time. So I'm going to add 6 at the end, and that's it. That's my recursive rule. If you want to make it look nicer, you can go ahead and rewrite your a sub n minus 1 and then just add the plus 6 at the end. But that's really it. That's all we had to do. So let's look at that next one. So it wants us to write the rule. So right away, I'm going to write down a sub 1, and then a sub n, and then a sub n minus 1, and leave just a little space here and here, just in case. Depends on what you need, right? And let's take a look at what's happening each time. So I do know that my first term is 4, so we can write that down. And then what's happening each time? So to get from 4 to 12, 12 to 36, 36 to 108, 108 to 324, to me this doesn't look like you could be adding. It's growing quicker than that. So I'm going to think, well, from 4 to 12 we multiply by 3. Is 12 times 3 36? Yeah. Is 36 times 3 108? Yeah. 108 times 3 324? Yeah. Sweet. So it looks like it's multiplying by 3 each time. Because it's multiplying by 3 each time, we just place that 3 out front, and that's it. We did it. All right. So I've got one more problem for you, and that's a word problem. This is a lot like a question on your test, so you might want to take a good note on this one. It's kind of a similar format. So a mosquito population in a controlled laboratory condition is estimated to be about 500. Ugh. All right. So each day, an additional 100 mosquitoes are hatched. Ugh. The population also declines by 85% from pesticides and other natural causes. So it wants us to write a recursive rule, find the number of mosquitoes after the 5th day, and also evaluate a little bit. We'll describe what's happening over time. All right, so to write a recursive rule, remember, we need our first term, and then you write your a sub n equals an a sub n minus 1. Put that in the middle, leave a little space. So it does say up here that the mosquito population is estimated to be about 500. Okay, so that's where we're starting. So I'm going to write down 500 for our first term. Now, something else that it says is that each day an additional 100 mosquitoes are hatched. So that to me sounds like addition. We're adding 100 each day. But something else that it says is that the population also declines by 85%. So that's some multiplication there. So the way that you do that is you want to take 100 minus 85%, and that's 0.15. So you're going to have to do that on your test too. You're going to have to do some subtraction to find this number. So that goes out front here. Okay, so we wrote our rule. Awesome. Now it says find the number of mosquitoes after the 5th day. Okay, well, we could make a little chart if we want to, like a day and a population, just to help keep us nice and organized. So Day 1, well, we know that. We're at 500 mosquitoes, right? And we've got a day 2, day 3, 4, and a 5. Okay, so what you can do, and I'll kind of show you a calculator trick with this, but our rule is that we take 0.15 times 500 plus 100 each time, right? So I'm going to, in parentheses, put 0.15 times 500, and then I'm going to add 100. So that means that my next number for day 2 is 175. Now you can keep typing that in. Like you could do now 0.15 times 175 plus 100. You could for sure do that. But if you don't want to type this out each time, what you can do is take 0.15 times, and then if you click second and then the answer button, which is the negative number sign right next to the enter. So if you click both of those buttons, second answer, parentheses plus 100, it'll continue to do it as you click enter. So enter, that's day 3, 126.25. And then enter again. Okay, so that's just about 119 for day 4. Oops, not 199, 119. Oops, I'm sorry. And then, okay, that's just about 118. And now we have day 5. Okay, so now it says describe what happens to the number of mosquitoes over time. Okay, well, I mean, it looks like it's going down. And then it kind of stays in this 119, 118. So maybe I'll click enter a couple more times and just see. Okay, so once we hit day 5, the number of mosquitoes pretty much stays the same, right? So what this means is after repeated calculations, the answer approaches about 118 mosquitoes, which is still too many for me. Okay, and that was the end of our videos for sequences in chapter 12A. You can go ahead and, if you're taking this class, make sure you go and take a look at the homework and use your notes and videos to help you. Thank you.